in many of the CSAT problems, we need to understand what LCM is, least common multiple, is to solve the questions. So we need we need to know how we can quickly find the LCM of the given. Find the LCM of the set of given numbers to solve some questions. So if we are given A, B, C, D, some random numbers, then when we say that the LCM of these numbers is, say, P, LCM is P, what we mean is P is the smallest number that uh, uh, we can come up with, which each number we can divide each number with P. That is, A divides P. P by A will be a natural number, and P divides with B, and P divides with C, and P divides with D. So all this will not give a fraction, and that is all A, B, C, D will divides with P, and satisfying that P is the smallest number that satisfies this condition. So for example, when we say that when we say 2, 3, 8, 5, when we are asked to find the LCM of 2, 3, 8, 5, the LCM here is 8 into 3 into 5, or we can say 4 into 3 into 10, or 120. The LCM is 120. We will just see how I found out the LCM as 120 later in this video, but LCM is 120. What is this 120? Each number, we cannot find a smaller number than 120 such that each number divides with this number. So 2 divides with 120, so that is 120 by 2 is 60. Similarly, 3 divides with 120, 120 divided by 3 is 40. Similarly, 120 divides with 8, 120 divided with 8 is how much? You divide 4, 60, 60 by 4 is 15. Similarly, 120 divides with 5 also. 120 divides with 5 gives 2, 24, right? Find 2, 10, 24, 24. So we cannot find a smaller number such that every number will divide with that number. Okay, so this is a concept. This is what we mean LCM of a few number is the least common multiple. Least common multiple. So least common multiple, that is the smallest number that we can find such that each number will divide with that number. So that is why least common multiple. Okay. So this is the concept of a least common LCM, and places where this comes useful is if we want to find in scenarios where say it is said that a bell rings, 4 bells, there are 4 bells, say B1, B2, B3 and B4. So for every this bell rings every 2 seconds. After every 2 seconds, this bell rings after every 3 seconds, and this bell rings after 8 seconds, and this bell rings after 5 seconds. So if we are asked at what time does all this bell ring together, so we know that if you take B1, it first it rings at second, then after interval of 2, right? So 4, 6, 8, it goes like this. So second bell, if you consider, it rings in every 3-second interval. So 3, 6, 9, it goes like this. 12, it goes like this. So B3, 8, 16, 24, 32, it goes like this. Okay. And sorry, this is B3. And B4 rings in every 5, 10, 15, goes like this. So when we are asked, there are 4 bells like this, and at what time they strike together or ring together. So there will be some number which is common in all this row. First number that comes common in all this row is the time at which all bells ring together, right? So let's say there is a number like here, P. This P appears in every row. So P is the smallest number that appears in every row. So if there is such a P, then that means at pth second all the bell rings together. So we need to find P. So here, in other words, we are asking for the LCM of 2, 3, 8 and 5. So this is where LCM comes into play. So P is, as we found out, if we find out the LCM of 2, 3, 8, 5, we will get 120. So here P becomes 120. So whenever we want to find out this, like the smallest element, smallest number that comes in rows like this, so we will look for the LCM of these numbers. So there will not be a smaller number than 120 which appears common in all these rows. So P is the smallest number that appears first in all these row common. So 120. At 120th second, all these B1, B2, B3 and B4 rings together. So in such questions, we use the concept of LCM. We can come up with many other questions also where we use the concept of LCM. We'll as we solve the CSAT problems, we will see how the concept of LCM comes in handy in exams. So the next question is, for people who are unfamiliar with this concept of LCM, how we can easily find this LCM. If we are given 4 numbers, how we can find this LCM? So before I will just say, before going to discuss how to find the LCM, I will just ask a simple mathematics question. So if you are given 4 numbers, say find out, if you are asked find out which is the smallest number that find the, if you are asked find the, which is not, find the smallest number, find the smallest number that divides with, that each number divides, that is divisible by each number given. So if you are asked something like this, they are asking to find out the LCM of the given numbers. LCM of numbers given. Just this is what I discussed. I just wrote it down only. Okay. Anyway, this is the concept of LCM. And now LCM comes. Similarly, there is something called HCF also. I will discuss that in another video. Highest common. It is called highest common factor. So LCM and HCF usually comes it's in one category. Like I will do another video on HCF. Anyway, we'll now see how we can quickly find the LCM of some given numbers. So whenever there are, I'll just from first case 2, 4, 8, 16. Whenever such, this is case 1. We are given 4 numbers. We are asked to find out the LCM. So once you understand what is the concept of LCM, then you can quickly find out the LCM in certain cases when you see the numbers. So what is LCM? LCM is the smallest number that we can find which is divisible by all these numbers. So if you see, all these given numbers are just multiples of 2. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. So the largest number here is 16. Any number less than 16 will not be divisible by 16. So LCM has to be 16 or above, right? And if you observe 16, if you take 16 as 16, 16 is divisible by 16, and 16 is divisible by 8, 16 is divisible by 4, and 16 is divisible by 2. That is 16 divides with 8, 16 divides with 4, and 16 divides with 2. Since 8 into 2 is 16, 4 into 4 is 16, 2 into 8 is 16. So right away we can see the smallest number that each of this number divides is 16 itself. So without writing anything, in such cases we can say LCM is 16. So so this is how understanding the concept of LCM rather than just mugging up some mechanical way to find LCM comes useful. So if we understand this, what LCM means, we can quickly, in such cases, we can quickly find out LCM. So we just see whether there is some the largest number gets divided with every other number. So this is how we can find out LCM in such cases. So we'll come up with another case. So say there was one more number 2, 3, 4, 8, 16. So in such case, if you see 16, again all 2, 4, 8, 16 is there, but we have one more number 3. So if you see, if you take 16 as LCM, 16 does not divides with 3. 16 by 3 is a fraction. So 16 cannot be the LCM, since the LCM is the smallest number that where every number divides by 3. Every given number should divide that LCM. So 3 is not the LCM. So one small, if you see, the more you if you have the intuition, sorry, one second. Sorry. If you understand what LCM is, you can quickly come up with the answer in this case also. So if you see 16 into 3, if you take 16 into 3, all the number now divides with this number. There cannot be a smaller number than 16 into 3 where each number divides with that number. So 16 into 3 is, so 8, 6 into 3 is 18, 8, 1, 3, 4, 48. So 48 is the smallest number where each number divides that number. So why is that the case? So if you see in 16, if you break down 16, it is 2 into 2, 4, 4 into 2 is 8, 8 into 2 is 16. And if you add, so we need LCM to be the number that divides each number, right? So here it divides, 16 divides with 2, 4, 8 and 16. But there is no 3 in this. So if you add one more 3 in this number, so we will get a number where each number divides with this and that will be the smallest. So including 3 and a number that divides with 16, this is the smallest number one can come up with. So that's how we get 16 into 3 as LCM. So in this case, 16 into 3 becomes the LCM. So we'll just look at another case where there is no pattern like this and we are given some mixed numbers. So 2, 3, 4, 5, 8, 9. So we are given this much numbers. Now we'll see how we can find LCM in such case. For that, we could do one thing. So we build up like this, right? So just like that, we can build up the numbers from here. Whenever there is some number, we will see whether our buildup of elements divides with that number. If it does not divide, then we will see what has to be added to get that number. Okay, I'm not confusing. I will just show you what I'm talking. So first number is 2. So we'll start building up our LCM. So LCM has, now it is, there is no number, so it will just 1 into, so 2 for this LCM to get divided with 2, we need 1 2. So we'll write just 1 2. Now we have second, we will go to our second number. So second number we need 1 3. So we'll see whether LCM has 1 3 in it. No, there is no 3 in it. So we'll just write 1 3. Now we'll go to the another number, and our next number 4. In 4, if you see whether there is 4 in our LCM, there is no 4 in it, but we have 1 2. So we just need one more 2 to have 4 in it. So 2 into 2 becomes 4. So this number has 2 in it, 3 in it, and 4 in it. So that is okay. So if we had only 2 3 4, our LCM becomes this. So we had more numbers, so we will continue building up our LCM. So there is 5 coming. So whether there is 5 in it, no, there is no 5 in this. So we have to multiply with 5. So 5. And now comes 8. 8, if you see, already there is 2 into 2. So there is already a 4 in this. So we just need one more 2 to have 8 in this. So 2 into 2, 4. 4 into 2 is 8. So we now have all 2, 3, 4, 5, 8 in this. Now there is one more number 9. So if you see, already there is 1 3 in this. So we just need one more 3 to have 9 in this. So 3 into 3 becomes 9. So all numbers are covered. This will be our LCM. So what is this? If you see, if you multiply for easiness, 5 into 2 is 10. So we'll keep that separate. So 3 into 3, 9. 9 into 4, 36, right? 36 into 10, which is 360. So our LCM is 360. So this is how we find out LCM if we are given some random numbers. So once you start, once you do some practice problems like this, once you start finding out LCM, just write down some random numbers and try building LCM like this. Once you have done enough questions, you will realize that you don't have to write all this. You don't have to build LCM by writing down each elements like this. You can simply look at the numbers and find out LCM in a more efficient way. So if you see, we know that there are some prime numbers. The prime numbers are 1, 2, 3, 5, 7, etc. Right? So if we know that if there is any prime number here, that has to be in LCM. So 2 is prime number, 3 is prime number, 5 is prime number. So we know that 2 into 3 into 5 has to be there in the LCM. So 10 into 3, 30 will be there in the LCM. Now we have 1 4 in this. So we will just look at what is the composition of 4? It is 2 into 2. So there has to be one more 2. So 30 into 2, 60. So 60 has to be there. Then we will see what more number have we have. We have 8. So we already have 4 here. So since our LCM divides with 4, now all we need is just 2. So we'll just go 60 into 2 is 120. Again we see 9. If you see, there's already 3 in this, so we just need 1 3. So 1 3. So this becomes 60 into 120 into 3, which is 360. So we can find out in a more faster way as you solve more and more problems. You don't have to write every single element like this, but if it is very confusing to you in the initial stage, just write down all one by one like this. So that's how you find LCM of numbers. I hope you understood that. Since I wrote only few lines in the note, so I think for some it may be confusing. For people who are new to this, new students who have no either forgot what LCM is or are new to this, may find it confusing. If you're confused and need a better, simpler video, just comment. I will try to make it a more simpler video with better explanations. But if you understood the concept, that is well and good. You can practice problems and you will get faster at calculating LCMs. So this is what LCM is, and the concept, where we use the concept of LCM and how to find the LCM fast. So I will be referring this video in questions that need to questions that uses the concept of LCM. So okay, that's why a lot of questions have the concept of LCM in it. So I thought of making a separate video rather than explaining the concept of LCM in every questions that has LCM. Okay, anyway, so I hope this is useful. Thank you.